In example 5 here, we are doing some more binomial probabilities. In this example here, we're looking at children in our society that are being raised by grandparents. Unfortunately, that happens all too often. And let's say that in a random sample here, 25% of grandparents here were raising their grandchildren. And where we want to know if 20 randomly chosen grandparents are considered, what's the probability that exactly 8 are raising their grandchildren? Probability that more than 1 are raising their grandchildren, and then between 1 and 5 are raising their grandchildren. So this is binomial because either they are or they aren't raising their grandchildren. The trials are independent. If we pick one set and they're raising their grandkids, has no effect on the next set of grandparents, whether they are. Probability stays the same all the time, 25%. So actually our P is 0.25. And then we have a fixed number of trials. We're selecting 20 sets of grandparents, so that's our N. N is 20. And so here we want to know what's the probability that exactly 8 are raising their grandchildren. So in symbols, we would write that like this: probability of 8, or probability X equals 8, either one of those. So if it's binomial probability, we're going to do binomial PDF if it's only one value. So we're going to do binomial PDF. And then we do the number of trials, the probability, and then our X value. So 20 trials, our probability 0.25, and then X was equal to 8. So let's go ahead and key that in the calculator. So second variables, we're going down to binomial PDF. So be careful here, PDF. Trials are 20, enter. P-value was 0.25, enter. And then 8 is our X value, enter, paste that, enter one more time, 0609. So about 6.1% chance that 8 of those grandparents would be raising their grandkids instead of the parents. What's the probability that more than 1? Okay, so that's asking what's the probability that X, our success, quote-unquote success, is the grandparents are raising their grandkids. So what's the probability that X is more than 1, greater than 1? Well, remember, binomial CDF does less than probabilities, less than equal. We want a greater than. So we got to use the opposite here. So we got to do 1 minus the probability that X is less than equal 1. So that's going to be 1 minus binomial CDF. And then we are going to put in that 20.25 and 1. So let's go ahead and enter that in the calculator. So let's see here. I'm going to do 1 minus second variables. Come down to binomial CDF, enter. Trials are 20. P is 0.25, enter, and our X value is 1. Let's paste that and enter. So 1 minus binomial CDF gave us 0.9757. So almost a 98% chance that more than 1 set of grandparents is raising their grandkids. And then lastly, what is the probability that between 1 and 5 are raising their grandkids? So this is saying the probability that our random variable, our X here, is strictly between 1 and 5. Well, we have to write this in terms of less than equal probabilities, right? So strictly between 1 and 5, that's going to be 2, 3, or 4. That's what we want there. And we don't want to include 0 and 1. So what we're going to do is we're going to do the probability x is less than or equal 4, and then we'll subtract off the probability that x is less than or equal 1, and that'll leave us with 2, 3, 4. So if you want, you can write this as probability that 2 is less than or equal x is less than or equal 4. And then we're going to do binomial CDF up to 4. So that's going to be 20.25, 4. And then subtract off binomial CDF. So C stands for cumulative, by the way. 20.25 and 1. So the probabilities from 0 up to 4, take out the probability from 0 up to 1, that leaves 2, 3, and 4. So let's go ahead and key this in. So I'm going to clear this out. So we got second variables, come down to binomial CDF. There. N and P are the same, we just have to change that x value to a 4. Paste it, minus second variables. Go down to binomial CDF again, enter. 20 and 0.25 stay the same, change our x to a 1. Paste it, enter. 3905. Okay, so that's the same thing we were doing up above, but this is in the context of an applied problem. They just didn't give us n and 0.25. We had to decide them from the problem, and we had to decide what this meant because they didn't write out the symbols for us. So we'll try homework 5.3 in Canvas, problem number 6, and see if you can get that to work out. Should be similar to this example. So you got to decide your P and your N to begin with. If it's only one value, you're using PDF. Everything else write in terms of a less than equal, because that's what CDF gives you, is less than equal probabilities. Give it a try.